All right. Well, hello, everyone. Um, I'm Aaron from DataStax, and today I'm going to take you through building a GenAI application with Cassandra, AWS, and Langflow. So yeah, that should be yeah. This should turn out to be really cool. Let me just figure out. Is this the share screen button? No. Sorry, we Oh, it'd be the button that says share. That's probably yeah. That'd probably be good to start with. All right. So anyway, yes, here we are. Welcome. Yep, building GenAI applications with Cassandra, AWS, and Langflow. The idea here is that if you've been paying attention to everything that DataStax has been doing with Langflow over the past past while, you'll notice that a lot of Langflow, at least the examples that we've shown, have worked with AstroDB. We've brought up a few, we've created a few lately that work with DSE, DataStax Enterprise. Now the thing is that those are both using the data API, and of course with traditional open source Cassandra, you don't have the data API available. So essentially, this webinar is going to show you folks who are still using open source Cassandra how you too can get in on building really cool generative AI applications with Langflow. So, all right, here we go. So again, kind of the main thing. We're not going to spend a whole lot of time in my slides here. We're going to go over a little bit of the architecture, and then I'll demo the rest of it out. Just how you would stand the rest of this up and get Langflow to run with Apache Cassandra. All right, so some quick definitions of terms. This is going to be based in AWS, and our Cassandra cluster is going to be running inside of Amazon EKS, or Elastic Kubernetes Service. You'll also hear me talk about Amazon ECS, which is a little different, Elastic Container Service, that lets you take Dockerized images, put them in your AWS account, and run them actually as containers out in AWS Cloud Resources pretty seamlessly, actually. And then, of course, there's the ECR, or Amazon, Elastic Container Registry, which is basically where we're going to send all of our images that we want to run as containers inside of ECS. And the reason that this is important is because these last two, the ECS and the ECR, anyway, we're going to use them to actually run Langflow out in AWS. So that's why those two are important. All right. So I've gone over this before, in a couple of the other live streams that I've done, but with Amazon EKS, we are using DataStax Mission Control to kind of abstract Kubernetes away a little bit, just to make things a little bit easier to create new clusters, manage new clusters, handle things like like repairs and backups and whatever else that you might need. And on top of, or rather, on top of DataStax Mission Control, we're using that as like a deployment platform for things like DataStax HCD, or Hyperconverged Database, DataStax Enterprise, and of course, Apache Cassandra. So that's what we're going to go with today. Additionally, just having something running out there in the cloud isn't enough on its own. We need an application. Like I alluded to on the previous slide, our application is going to sit on top of Amazon ECS. And actually, that application is going to be Langflow. So I'll show you how you can pull down a Docker container of Langflow, or a Docker image of Langflow. And then we'll go ahead and push that into Amazon ECR, then build a new service in Amazon ECS using that image. And hopefully this will all work together great. Now, you might be asking, you can't really use Langflow, especially if you want to do something that requires embeddings and working with LLMs without a vector store. Well, fortunately, Cassandra has been a vector store as of version 5.0. We can thank our founder, Jonathan Ellis, who has gone out and created the JVector library that we use inside of Apache Cassandra. And I have the link to his GitHub project here. It's just, out at github/jbellis/jvector. And, you can see how Jonathan put this all together. He did have some help, of course, too. But the idea here is that this is what AstroDB is running on top of. I think AstroDB is running on top of JVector v3. And then currently in Cassandra 5 is JVector v1. So this is what actually kind of makes all of this possible today when we're building like applications that are built on the Retrieval-Augmented generation or the RAG paradigm. It's important to have a vector store underneath, and Apache Cassandra does that. Okay, of course, without the data API, we have to connect over 9042. Now, those of you who have used Cassandra for a while, this should not be, a revelation at all. CQL over 9042 is kind of a known thing. The way to get to that in a Kubernetes environment, you can see I have the kube control command on the bottom there, is we're going to take our cluster service and we're going to expose it as a load balancer with that target port of 9042. And that's going to allow traffic to on that port to get to our cluster. So that's a key step, and we'll walk through that as well. Additionally, to connect up, we're going to need our username and password. Now I know I've shown this before, but when you create a excuse me, when you create a cluster inside of Mission Control, your credentials get stored as a Kubernetes secret. The way to get that is to go ahead and do a kube control get secret and then the name of what user it is, and by default mission control will create a new cluster with a like the name of your cluster dash super user, and that's what we'd log in with initially anyway. But the username and password for that secret are actually like base 64 encoded. So they'll actually come back in the encoded fashion, and then you have to go ahead and kind of decode them in order to use them. And that's important too, because we will need our username and password along with our endpoint to connect up. All right, like I said, we weren't going to spend a whole lot of time on slides. So really, this is what we're going to do for our demo. Kind of what I just talked about in the last few slides. We're going to create that load balancer on port 9042. We're going to pull down the Langflow Docker image, retag it, and then push it to our Amazon ECR. Then we'll create a new service inside of ECS using that image. And once we get Langflow up and running, we'll create a new flow that will work as an AI shopping assistant. So, hey, lots of stuff coming your way here now. Let's go ahead and push forward. All right. So to start with, I'm going to go to DataStax Mission Control. Yeah, maybe I should get Slack out of here, huh? That's probably a good idea. I will need my terminal. Yeah, this should. Let me just see how much room that all takes. Here, let's jump to a DataStax one. That'll be good. Okay, got that set. All right, so Mission Control. If I go ahead and click on the clusters option in the left nav here, you'll see that I get a little more detailed overview of the clusters that I have available inside of Mission Control. And you can see I have this cluster named Fly By Night that is running on Cassandra 5.01, and that's the one that we're going to be using today. I also have an older version of DSE out here that I've been messing around with, but we're not gonna touch that today. All right. So if I go and have a look at this cluster, you can see I have a data center named Anthem. I have 3 nodes, and all are up and running. So we should be in good shape here. Let's go ahead and have a look at the services that we have here. So I can do a kube control. Let's say get services namespace, and my namespace is Aaron's Proj, and then it has a unique slug of like, what is it, 5HC6UEXB. All right, and then just to make sure that we're getting the resources back for the cluster we're going to use, we'll just throw on a grep of fly by night, just like that. Okay, so you can see here that that we have our fly by night Anthem service. It does go ahead and throw out the or offer that port of 9042 available. Now you'll notice I actually already do have the load balancer out here. You know, there are some things that I didn't want to take chances on a live demo, so I did make sure that I do have that out there. But I will run through the command here quick without running it, just so you folks can kind of see what it is. So if I was going to do that, I'd say let's go kube control, and we'll say expose service, and we'll be doing, yeah, it's going to be this this fly by night Anthem service like that. There we go, and we're going to say dash type load balancer. We're just going to name it. Well, as you can see there, I already named it. You know, we'll say fly by night LB. That should be fine. And then again, we'll go ahead and make sure we paste in the right namespace. And then also important, make sure we specify our port of 9042 and our target port of 9042, just like that. This should go ahead and expose that main service as a load balancer that we can go ahead and we can hit later. The other important thing here to remember is that when you connect up to Cassandra with Langflow, it can't hit a DNS name. You know, so if I have this is what resolves out from that load balancer. This is the DNS name. Well, you know, I can go ahead and hit that for most normal applications, but Langflow is not going to allow Cassandra to connect up that way. So what I need to do is get the IP address, and again, just a quick trick to do that. I'm just simply going to do a ping. Oh, not pint. Ping. All right, and of course that's going to fail because we block the ping port by default. But excuse me, what you can see is I do actually get the IP address out of that load balancer. So I'm just going to go ahead and save that off here for later. That's going to be important. All right. So the other thing I need to remember, I did mention about the credentials. So let's go ahead and do a kube control, and we'll say get secret, and would help if I spelled secret right. And we're going to say fly by night super user to get the default. And let's also go ahead and make sure that my namespace is pasted in there properly. And we want to output that, say -o as a YAML, just to kind of format that appropriately. Okay, so if I run that, you can see up here that secret shows up. I have the username and password. They are both there, encoded base 64. Now, if I actually want to see what that is, I can go ahead and do a echo, and let's just demo this with the username. I'm not gonna decode my password here. I get yelled at by security when I do that. So let's just go and say, yep, we'll echo that, and then I'm gonna pipe that to B crypt. Oh, no, I'm not. That's Java. Sorry. I was thinking with the wrong part of my brain there. Base 64. That's it. And then I'm going to pass a -D for decode. And you can see when I do that, I get the actual username back here. So, of course, if you're going to do the password, going to want to decode the password from this up here, you would take that exact same step, and you could decode that. All right. Okay, next, let's go ahead and have a look at Docker here. So if I say Docker pull, and we're going to pull this from Langflow. Oh, I need to spell that properly. Langflow AI. Langflow. There we go. As you can see, it does pull that down to my local. This might take a little bit, depending on your connection, but not too much longer. And I'll just kind of talk through this too. The next thing we need to do is retag it with our Amazon ECR registry endpoint. So I'm going to do that next as well. Excuse me. Almost done. Hey, there we go. All right. So we have a newer image. Okay, outstanding. All right. So now if there's a window I forgot to bring over here. If I have a look at Docker, you can see that I do in fact have Langflow here. And this was this is the most recent one. And you can also see that I've gone ahead and retagged it already, so that you can see that it matches up with our Amazon ECR endpoint, and that's important because then we can do a Docker push, and it'll actually end up inside of our registry. All right, so let's go ahead and let's see here. I'm looking around in my notes and I'm wondering where I got this one. Well, let's see here. Let's just go. How about grep, and then you can say Docker. Actually, there we go. All right, so you can see that the last time that I had to do this is right here, actually. So this is the identifier for that image on my local. I went ahead and retagged it with this URL right here that goes to my my Amazon ECR. And you see that goes to DataStax. Actually, I built this registry for all the demos that we ran during Amazon reInvent. And that's why that's still out there. So that goes to DataStax reInvent 2024, and then in the end I have the the mention of Langflow. So normally this is where I would do like a like a Docker push. So I could say like let's go ahead and re-up that and say push. Yeah, there we go. So you can see this is where I've gone ahead and sent up Langflow in the past. So if I actually look out here now in Amazon ECR, and you can see that out in our repositories, we have a couple. I'm going to pick this DataStax reInvent one here. And yeah, we have an image out there for Langflow that we can use. So what I'm going to do is I'm actually going to copy the image URI right here. So I'm just going to click that and kind of store that off just in case. Usually the ECS, the Amazon Container Service, does a pretty good job of like I just got caught up in the comments for a second there. Yeah. Usually Amazon ECS does a pretty good job of like kind of auto-filling the available image URIs. But I like to copy it just in case because I've had it not find it all the time in the past. Anyway, so let's go here and we're going to click on ECS, or Amazon's Elastic Container Service. All right. And out here, you can see I have the aptly named reInvent cluster from, again, all the demos that I built for reInvent. There's currently nothing running out here, though. See, if I go ahead and restart or refresh, I should say, nothing shows up. So what we need to do is create a new task. And I can go to task definitions, and you can see I actually do have a Langflow task out here. But let's create a new one. Let's say Langflow. We'll just call it Langflow LiveStream because, well, that's kind of what we're doing here. All right, let's go down. Make sure that when you run Langflow to use Linux x86-64, the container or the Docker image itself is not built using an ARM processor. So, I know you've probably, anyone who's used Docker a bit on the new Macs, like the M1 through M4 with the ARM processors, has probably run into like an invalid OS at some point. So again, with Langflow, just make sure you're using Linux x86. That's going to be kind of important. Okay. Default task role is fine. Task execution role is fine. Let's name this Langflow. I'll just call it Langflow Live. Okay. Remember we copied off our image URI. This is where we're going to paste it. So I'm just going to go right here. Yeah, you can see it. It has a bunch of them that come up. Oh, you can see the different names of them kind of pop up there in there as I scroll. There's the Langflow one. So we'll go ahead and use that. It absolutely is an essential container. We don't really need port 80 exposed, so I'll just go over with 7860. That is the default port for Langflow. So when you're running Langflow on your own, that's what you're going to want to make sure you have there. We don't need any environment variables. I think the rest of this is all good. Let's just go ahead and create. Okay, so that's given us a new task. Next, we're going to deploy this task by creating a service. And same thing, it's going to auto-complete a lot of this. For our service name, we'll just say Langflow Live. That should be fine. The main thing we're going to have to adjust here is in the networking tab. The default VPC should be okay. Subnets are okay. The security group name. The default security group is usually not going to be enough. We're going to want a security group that has an opening for port 7860. So I have that named aptly AWS reInvent demos, and I know that security group has the ports open that I need for it. So that should be okay. Let's go ahead and do a create. All right. So that's spinning up. Sometimes it takes a couple of minutes to come up. If I go down and I hit the refresh here, you can actually see that the Langflow live service is on its way up. 0 of 1 tasks running. So yeah, this should be along in another minute or two. Oh, Tanya, I just now saw your note about wanting to increase the screen size. I do apologize for not noticing that until now. I hope you've been able to at least kind of see what we're doing here. At least a little bit. The good news is that this live stream will be rebroadcast later. It'll be available on our YouTube channel. You might even be able to watch it on, I don't know if LinkedIn Live lets you watch something that has already happened, but it will be on our YouTube channel. So you can go back and, watch it on a big screen or even zoom in a little bit. And you should find that helpful. All right, let's see how our service is doing here. Well, still on its way up. So anyway, once the service comes up, we'll go ahead and go into Langflow and create a brand new vector store reg flow. And then we'll go ahead and use that as kind of like the scaffolding, if you will, to build up our AI shopping assistant. Shouldn't take too much longer. Hey, there we go. 1 of 1 running. Outstanding. Okay. All right. So now if I go into our service, I should be able to look at our tasks. Yep. Here's our task that's running. And if I click into that, I get a public IP address. So I'll copy that. Now, I'm not going to say open address because that's going to try and open it on like the standard web port of like port 8080. And we definitely don't want that. So let's go ahead and create new HTTP. There's our IP address. And then we'll go to 7860. And if we did everything right, oh, it's doing something. All right. Outstanding. There's Langflow. Whew. That's going to be one of the more like shaky random weirdness things can happen inside of a live demo. So I'm glad we got this far. All right. So if you've never used Langflow before, essentially this is a component-based GUI, kind of sort of like an IDE actually, where you can drag and drop different components and build an AI application. It's really slick if you haven't messed around with it at all. So let's do a new flow. I'm going to say vector store rag. There we go. All right, and you start out with vector store rag. You actually get two flows inside of one. We're actually going to build out both of these here. The top one here is for the actual like AI assistant interactions as it goes back and forth with like the LLM and the chat model and the vector store, and kind of gets you your results. The bottom one here is just to load the data and generate the embeddings. So let's go in here, and here you go, Tanya. Here I can actually zoom in quite a bit, so I hope that's enough for you. Okay, so we have some components here that we're not going to use. First of all, this AI embeddings one, we're not going to bother using today. Under models over here, I'm going to grab Amazon Bedrock, and I'm going to drop that in. Oh, actually, that one's going to go up above. Yep. You know what? We're still going to use that one. Let's put that up here because I got to get rid of the I have to get rid of this OpenAI one. That's more of like the chat model. What we want is the embeddings model. And if I go down and then grab Bedrock, all right, there we go. There we go. We have Amazon Titan Embed V1. That is what we want. Oh, and I can delete that. That's not a big deal. All right. Let me go ahead and fill that out real quick. Uh-oh. All right. Let's try my access key one more time. There we go. Outstanding. Now, if you use for AWS, you use your access key ID and your secret access key. You don't need to mess with the session token. However, we are using US West 2, so I'm going to want to switch my region there. Okay, that should be good. Next, Langflow defaults to use. Oh, I can move this a little so you can actually see just basically where my head is showing up here. I can go ahead and get rid of the AstroDB connector because we're not going to use that. And let me go to vector stores, and if we just grab Cassandra, that should work. Okay, so let's connect up chunks with ingest data, and we can drop our chunk overlap to half that. And then let's run embeddings to embeddings there. Remember before when I went in and did a ping of the load balancer to get the IP address? That is where we're putting that. Username. Let's see here. I'm just going to do a username of here we go. Fly by night super user, and then my password. Oh, all right. For key space, come on in my notes. Yeah, here we go. I'm just using Langflow test, and then a table name. I'm just going to say Astra Peril AI, just like that. All right. let's double check something in mission control quick. So if I go ahead and sit in my CQL console here, and we say, and all right, and we say, what did I say? Langflow test, just like that. Okay, so the key space is empty, but the key space has to exist with this component before you can go ahead and run it. Okay, so we got that. The only other piece here is that for our shopping assistant, it needs to know about our product data. So what I'm going to do is click on our file component here and documents. There we go. products2.csv. So this will take just a standard like CSV file. This has all of like the product data. If you've watched any of the things that we did, any of the live streams we did on like our e-commerce workshop that I used to run a couple of years ago, that's where the product data is from. Okay, so if I have all this and I click the run button on Cassandra over here, and I've done everything right, it should go through the components and build everything successfully. Okay, that did it. All right, so, of course, it logged me out here. So let's go in and check our table real quick, or check our key space real quick. Ooh. Yeah, fat fingered my password. All right. There we go. Okay. All right. Now I can say use Langflow test. I say describe key space. Bam. You can see it created the table using two SAI indexes. And we actually have our vector column here, which is a float 1536 that matches up with the Amazon Bedrock Titan text embed v1. Okay. Now, if I check this table out, let's just do select star from Astra Apparel AI. There should only be like 20 rows in there, so doing a select star isn't too big a deal. But if I run that, hey, 24 rows, outstanding. And you can see, yeah, all the embeddings came through. Our product descriptions are all right here. So yeah, this worked really well, actually. Okay. And now just the last piece of this, we have the loading flow working. Now let's go ahead and create the chat flow. So again, I have this OpenAI embeddings component here that I'm just going to do a delete on. So the cool thing, though, is that inside of Langflow, I can duplicate components. And I'm going to do that with Amazon Bedrock to avoid having to retype everything. So let's take that and go there and hook our embedding model up just like that. I can also do the same thing with this AstraDB component as well. So let's just go here and say delete. Then I can go to the Cassandra component and I can say duplicate. And let's run that right back to here. All right. So I can go embeddings to embedding and then search results to data. And then I also have to run the chat input to the search query node. Okay, so that should be that. Yeah, we have to fix that. Let's have a look at the prompt here real quick. So if I go to the prompt and kind of click into here, you can see it's just a generic, like AI chat prompt. I actually have some rules, or what we call guardrails that we put in here, that I'm just going to go here and I'm going to paste them in. So essentially, I'm telling the chatbot, hey, You're a shopping assistant for the Astra Apparel online store. You must only answer questions about Astra Apparel products. You may only use the product data in the provided context and cannot use any other sources for answers. That part's really important, by the way. So this is going to force it to go ahead and use the data that's inside my vector store inside of Cassandra. And you must format your responses about product data like product ID, comma, description, comma, image. This was actually really important for building a demo at reInvent, just so that our front-end designers kind of knew what the format of the data was going to look like coming in so that they could parse it out appropriately. And then question and context. Very important, you still have that context up here because that's going to tie back to the vector store. And the question, of course, is going to come from the chat itself. So we should be able to check and save. I don't need that. Okay, so our prompt should be all right. All right, last step here. Let's get rid of the OpenAI LLM component. Let's just delete that. We have our Amazon Bedrock component, which our prompt is just going to tie right to our does tie to the input. Okay, I had to double check that. Oh, by the way, you can do Alt or Command Z to backspace over your actions in Langflow, as I just learned myself. So let's send prompt message to input. We're going to go text coming out of here to go to the chat output. For our model, I want to use Anthropic, Claude, Sonnet. Let's see here. Yeah, 2024 1022 V2. That's the one I want to use. Okay, so I've got that. And then let's go ahead and paste my AWS key and secret. And I have both of the Bedrock models I'm using authorized in US West 2. So I'm going to want to switch my region. I think that's it. So let's back out a little bit here. And if we hit this little run component button on the chat output or whatever is the last component, it should build a whole flow. And if we did it right, it should work. Or it should not throw an error. How about that? Okay, I'm seeing a lot of green so far. That's good. Outstanding. Okay. One thing that I could have done is that in this chat input has a sample question of what is the document about. I have a feeling that the AI assistant isn't going to handle that question very well. But what I can do is I can go to the playground here. Oh, yep, and it actually did say, hey, this is a product category or inventory list for Astra Apparel. You can ask it, all of these things. What I'm going to do is I'm going to say, can you help me find a hoodie? And it's going to think for a little bit. Sometimes these answers are they come along faster than others, but for the most part, it's usually like a little less than 30 seconds. Oh yeah, here we go. Look at this. So we have these products such as the DataStax Black hoodie. And then there's also the vintage MVP hoodie as well. And it has details on how many sizes it comes in. So again, I can ask the shopping assistant, I can say, please tell me more about the vintage 2015 MVP hoodie. And again, it'll go ahead and kind of look at that last answer that it gave, and then based on the context and what we have in the vector store, it'll kind of come back and it should have a little bit more detailed answer about that hoodie specifically. Yep, here we go. It's very warm and comfortable. You might find yourself falling asleep while wearing it. Given out to MVPs at the 2015 Cassandra Summit. So this is totally working. Excellent. All right, let me bounce back to my slides here. So yeah, thanks for joining me on this one. I wonder if I can move. Well, I can't really move my picture in picture around, can I? Maybe I can. No, that doesn't really help either, does it? No. Well, I mean, this is okay. We have a Discord server. So if you're using any of our products, or and you're having some issues with them, you can head on out to Discord GG/DataStax. That'll get you an invite for our Discord server, and we can help you out there if you have questions with like Astra or DSE or HCD, or even Langflow, and as well as any of our libraries and things that you're using to build like an AI application. We can totally help you out there. Additionally, I mentioned our YouTube channel, DataStax Developers. That's where this video is going to be. And we also have a whole bunch of other videos and content out there for you to check out. So again, if you get stuck on something, or you want a quick tutorial on like how to do something with like mission control and DSE, and maybe build an application on top of that, we have lots of things out there on that. We have great detail out there on Langflow as well, and how to build on top of that. And of course, I mean, feel free to check out datastax.com as well. I know that there's one URL in particular here that and now I'm not finding it, of course. Oh, yep, here it is. Here we go. It's our modernized Apache Cassandra. Oh, I can add myself back in now, probably. Yeah. This is our modernized, Apache Cassandra workloads page. We have all kinds of resources out here. Whether you're using fully managed Cassandra out in the cloud somewhere, or like DSE or Cassandra on your own Kubernetes. You need enterprise support for open source Cassandra. We can totally help you out here. If your Cassandra, footprint needs to go through a cloud migration, we have all kinds of steps and resources here that can help you out. So I highly recommend heading out to this modernized Apache Cassandra workloads page. I'm pretty sure that Michelle has a link to that she's added in somewhere here. But short of any technical questions or anything, I think that's about it. Let me just click. Q&A tab looks empty. I don't see any more in the chat. I suppose we can just end it here. So yeah, like I said, this is just a great way to show that even with an open source, like Voltron in the background. Yeah, outstanding. I was just going to say that even with open source Cassandra, you can still get in on building out, all of the recent, applications with the recent AI developments, and Cassandra can totally support that. And you can even use something, that's cool and snazzy looking like Langflow on top of that. So yeah, thanks everyone for joining, and have a great day. We'll talk to you later.